All right, guys. Here we are looking at the review for the polygons and quadrilaterals, which, of course, quadrilateral is a polygon. Knowing the formulas for polygons will help you a lot here, especially on these first several problems on the review. Number one, find the measure of an interior and exterior angle for a quadrilateral. So we are assuming that this is a regular polygon, otherwise, the formulas wouldn't work here. There's a couple ways to do this and a couple things to remember. An interior and an exterior on a regular polygon are supplementary. That's supposed to be an 8. They add up to 180. So if you can find one, then the other one you can just subtract from 180. To me, the easiest way to do this is to start with the exterior. The sum of the exterior is always 360. So here, if I divide that by 4, you get 90 degrees. And then for the interior, you can do 180 minus 90, which is, of course, 90 also. And those will be your two answers, interior and exterior. Now, if you don't want to do that way, don't forget the interior formula, which is the sum formula divided by the number of sides. So you could have also done 4 minus 2 times 180, which is 360 divided by 4. Okay, that works either way. Find the sum of interior angles of a nonagon, number 2. Nonagon is 9. So 9 minus 2 times 180. 7 times 180 is 1,260. And that's it there. A regular polygon has an interior angle measure of 108. What is the number of sides of the polygon? When they give you an interior angle measure and they want to find the number of sides, this is a two-step shortcut. Otherwise, you'd have to do a lot of algebra. But basically, you start by subtracting the angle from 108, which here is 72. Step 2 is to take 360 and divide by the answer you just got. So the answer you get for subtracting should go into the denominator, and that's going to give you the number of sides, which in this case would be a pentagon. Speaking of pentagons, number 4, find the measure of an exterior angle for a regular pentagon. Again, the sum of exterior angles is always 360. You divide that by the number of sides of a pentagon, and a very easy 72 degrees. The measure of 3 exterior angles of a quadrilateral are 65, 106, and 78. Find the measure of the fourth. Exterior angles. Now, quadrilateral again is special because quadrilateral is the only one where the interior and exterior sums are the same. It's 360. And the individual exterior is the same, 90 degrees. But make sure in a question like this you pay attention that they're talking about exterior angles here, because the sum is 360. 3 of the angles are 106, 65, and 78. You add those 3 together, you're going to get 249, and you're going to subtract that. Now, the general idea here is the same for all problems, but just keep in mind, if you're talking about an interior angle, it depends on how many sides you have. Pentagon equals 540, and so on. Use that formula. If it's exterior, no matter how many sides it has, it's going to be 360. 4 properties of a parallelogram. I guess we'll kind of write these real quick. Opposite sides parallel. Think opposite to begin with parallelogram. Opposite sides congruent. So the sides across from each other are both congruent and parallel. And then one more opposite. Opposite angles also congruent. Four, consecutive angles supplementary. In general, in a polygon, in a parallelogram, whatever angle you start at, if you go down to one or to the other, they should be supplementary in either direction. So, just in general, if that was 170, that would be 110 here and here. And then, opposite angles were congruent, so notice across the same. Those are going to be parallel, those are going to be parallel, those are going to be congruent, those are going to be congruent. And then the fifth one, even though it only asks you for 4, is that diagonals bisect. So when you draw diagonals across, they bisect each other. Does not mean they're the same length, just that they will cut each other down the middle. Name 2 parallelograms that have diagonals equal in length. So I just said the diagonals in a parallelogram don't have to be congruent. So what's the first shape in that little family tree where the diagonals would be the same length? That's a rectangle. Because it's also true for a rectangle, it said name 2 of them, it's also going to be true for the square. Okay? All right, back up top, name the properties of the rhombus. So we're not going to rewrite all the properties we did in number 6. So all properties of parallelogram. So there's 5 here. It's harder to write with this thing. But what's the main one that makes the rhombus different from the rectangle or the parallelogram before it? 4 congruent sides. And then the other properties that go around that are about diagonals. This one has perpendicular diagonals. So inside the rhombus, there are 4 equal sides, and inside, where they cross, you're going to get 90 degrees. And then the last one is the diagonals bisect the angles. And that's going to come into play here in a couple problems as well. In a parallelogram QRST, the measure of angle T is 75. So you can just draw yourself a general parallelogram. And it doesn't matter where you start labeling it, as long as once you start, it goes in order. Normally we do clockwise, you can do counterclockwise, it doesn't matter, but I must go from Q down to R to S to T in one direction or another. If T is 75, kind of like I showed you just a minute ago, I should be able to go down either side from T to the next angle, and in both directions it's going to be supplementary. So specific to S, because it's next to T, angle S is going to be 105, 180 minus 75. Given the rhombus, find the measure of WXY. Remember that when you have 3 letters, the middle letter kind of tells you the angle you're talking about, but you have to follow the letters, so WXY is the whole angle X. Now, from what they give you, it doesn't look like you have enough information to give an answer here, but going back to the properties you wrote down, for number 8, it can help you out a bit. First of all, in a rhombus, the diagonals bisect the angles they come out of. So if that's 34 down there, that's 34 above, which makes this whole angle 68. Then you also just wrote that opposite angles are congruent for a parallelogram, and a rhombus is a parallelogram, so that's going to help give us our answer, which is 68. XYZ, so XYZ is then the other angle, and like we also just said, if you go down one road or the other, they're going to have to be supplementary in either direction. So 180 minus 68 is 112. And then it was supposed to be a T right here. WTX is an angle on the inside, and because the diagonals are perpendicular, that makes it 90. And the last question on this front page, given rectangle PQRS, find QPT. So again, middle letter tells us the angle. So it's right there. Now, rectangle, 4 right angles, means the big angle P is 90 degrees. If below that line is 62, it's not bisected, it's not 62 on top, it's 90 minus 62. So 10 minus 2 is 8, 8 minus 6 is 2. That angle is 28 degrees. PST, if you follow, where are we at? PST. Now, that's an interesting one because it doesn't seem like they give you information. But a couple things to keep in mind. I'm going to go back and erase some of this to help us out here. In a rectangle, the diagonals are the same length. So P to R and Q to S are the same length. And because it's a parallelogram, the diagonals cut each other in half. So what that means is that P to T is the same length as T to R, is the same length as Q to T, is the same length as T to S. Now over here, we've created a triangle with 2 sides the same. That's isosceles. In an isosceles triangle, the 2 sides match, and so do the 2 what we call base angles. So that's going to make that 62. QRS is simply asking about one of the 4 corner angles, which is, of course, 90 degrees. A lot of properties, formulas to remember, but once you do and understand them, this should take no time at all. Check for video 2 about the back page of this, and also keep an eye on the classroom. I'm probably going to add a video about quadrilateral properties to kind of help you out a bit there. All right, good luck.